going to be looking at solutions 3 of the statistics summer course. So let's get this onto full screen. And I'll just check the focus. Okay, so question 1, find the z-score for the area shown. There are a couple of ways we could do this. We could do this with charts, or we can do this with a calculator. Ask it to run. I'll put this over here. Let's see if I can make that icon go down there. Okay, if I have the left area, then if I do second vars and scroll down to INV norm, if I know the left area, then I should be able to get the corresponding z-score. And you can see here they're all taken to 2 decimal places, and if I take that to 2 decimal places, it's selection A. Another way I can do that is if I have a chart of the positive z-scores, because this is where 0 is, and so this z-score is a positive number. I try and find 0.8264 exactly in the body of the chart. And there it is, 0.8264. And I can see if I go out to the row, it's 0.9. And if I take it all the way up to the column, it's 0.04. And if I put those two together, I get 0.094. Okay. So another way I could do that would be by looking at the chart. Now, that one was very straightforward. We got to be really careful, though, when we have one like this, because we have not been given left area. And if I'm going to use the charts, it's all cumulative area from the left. If I'm going to use my calculator, I have to feed it in left area. So I need the left area. And since we have a normal distribution here, this left area is going to be 1 minus the shaded area. So 0.6591. Okay, so that's 0.3409. And again, if I want to look this up in the chart, I do have the left area now, but I'm going to need to use the negative z charts and look for a left cumulative area of 0.3409. 0.3409, there it is. There it is. So my row goes out to negative 0.4, and the column goes all the way up to 0.01. So negative 0.41 is what we would have there. Or, again, I can use second vars, go down here to selection 3, but I must tell it left area. And I can see to 2 decimal places, I've got the correct answer, D. Common mistake here is student just sees the shaded area and isn't thinking that it's right shaded, and what's needed is left shaded, and they end up instead putting 0.6591 into that, or look it up on the chart and get that, and look at selection C. So you have to be extremely careful here. Because the bogus selections are built in there. Okay, so we have to have left area. Now, calculate the probability that a z-score is less than negative 0.85. So if I wanted to draw a picture here, then what they're asking me to do is actually calculate the shaded area. Now, I've got the z-score, so I could look it up directly on the negative charts to get that shaded area, because that's what we want. So negative 0.8 and then 0.05 column and they connect there at 0.1977, which is what we want. Or if I have the z-score, so in these first two I had left area spoon-fed to me, and then in second one I could easily get the left area. If they're asking you for the left area and you have the z-score, then what we need on here is second vars, and I want to go down to selection 2. Now I want this area, so I have to give it a left limit z-score and a right limit z-score. Now obviously that's going to be my right limit z-score. And of course, as we learned in class, these don't ever touch. They keep getting infinitely closer, but they'll never touch. And so just to be safe here, if we're looking at left limits, give that -1000. So that's what I'm going to do here. Comma, and then give it the right limit, which is -0.85 or -0.85, same thing. And if I take this to 4 decimal places, if I round that to 4 decimal places, then that 6 there will bump this one up to 0.1977. Okay. Now, if I draw a picture for this one, I need the probability that a z-score is greater than 2.22. So there's 0, there's 2.22, and now they're asking us to find, because of the symbol here, we've been asked to find this shaded region. And again, I can get my calculator to do this shaded region for a z-chart, for a normal distribution here. I can do second vars, and again, go to the second selection. And if I want this shaded region, I have to give it a left limit, and I have to give it a right limit. And so here, let's just be safe and give it a z-score of, say, 1000. So let me do 2.22, comma, and then 1000, close parentheses. Okay, and that matches up to 4 decimal places with selection E. The other thing I could do is I can find 2.22 on the positive z-chart. When I do that, I get 0.9868. But what is that telling us? That's telling us left area. The chart always gives left area. And if you forget that, look at selection D. There's the bogus selection there. We want the shaded area, which is the right area. So what we want here is 1 minus 0.9868, and that's where we get selection E. Okay, I want to calculate the probability that a z-score is between -0.85 and positive 2.22. Well, there's a couple of ways I could do this. One way I could do this is I have my little picture here. So what they're really asking me for is this shaded region, okay? But look at questions 3 and questions 4. I know that the area to the left of this is 0.1977. Okay. I know that the area to the right of 2.22 is 0.0132. I did that from number 4. So if I want the shaded area, well, the total area is 1, and then I can subtract out that area and subtract out this area. There's lots of different ways we could do it. I could do left area of this minus left area of that as well. Lots of ways we could do this. Okay. So 1 minus 0.1977 minus, oops, okay, let me get it back. Where was I? And then minus 0.0132. Okay. Oh, sorry, my bad. Let's try again. 1 minus 0.1977 minus 0.0132. And I get 0.7891. Another way to find this shaded area using my graphing calculator is do second bars. Scroll down here to, the second selection. And again, I want to find the shaded area, but I have to give it a left limit and a right limit. So let's see how that works. And I'm getting the same answer, correct to 4 decimal places. Okay. All right, now we're on this part. Assume that the human body temperatures are normally distributed with a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.62 degrees Fahrenheit. So what we have here are raw scores. And first thing we have to do is convert the raw scores into z-scores. And once the raw scores are converted into z-scores, then everything gets solved like it was on the first page. Okay. So I need to convert 197. So remember, we have this formula. So if I want the z-score for a temperature of 100, that's going to be the score I want to convert minus the mean, which is 98.2, all divided by the standard deviation. Okay. So 100 minus 98.2, enter, then divided by 0.62. And that gives me 2.90. It's customary to round z-scores to 2 decimal places. Then I need to get this guy. What is the z-score for 97? Well, it's the temperature I want to convert, 97, minus the mean, all divided by the standard deviation. And I'll round that to 2 decimal places. So 97 minus 98.2, enter, then divided by 0.62. So if I take that to 2 decimal places, if I round it to 2 decimal places, this 5 is going to bump that up to a 4, so negative 1.94. So I want to find this shaded region. Now I have the z-scores, a left and a right. So I can do second bars, come down here, give it a left limit, which is negative 1.94. And then give it a right limit, z-score, which is 2.90 or just 2.9. And that's going to give me 0.9719 to 4 decimal places. Okay, now number 7 is asking me the exact same question as number 6. So number 7 was just a repeat to see if you can recognize that these are the exact same questions but in different forms. All right, now I need to find the temperature. I know the left area. If we know the left area, we can get the z-score. But they haven't asked for the z-score, they've asked for the temperature. Get the z-score first, then convert to x. Okay, so if the left area is 0.7019, a couple of ways I can do this, second bars. If I know the left area, which I do, then I can get the z-score. The z-score is going to be 0.53 if I take it to 2 decimal places. That is the z-score. We've been asked to find the temperature. So if you circle that, it's wrong. That's the z-score. Now we have to find the temperature. So the z-score, if I use my conversion formula, is equal to what we're trying to find, the raw score, minus the mean, all over the standard deviation. Now I have to solve this for x. So the first thing I'm going to do is multiply both sides by 0.62. So if I multiply both sides by 0.62, that cancels out. And I'm left with x minus 98.2 is equal to 0.53 times 0.62. I'm trying to find x. How do I get x by itself? I add 98.2 to both sides. So plus 98.2. And I'm going to get 98.5. And if I take it to 2 decimal places, 3. Okay, now find the temperature x, but this time we have right area. If I get the z-score, so the steps are still going to be the same, get the z-score, then convert it to x, but they've given me right area. I need left area. And what is the left area? It's going to be 1 minus the right area. .84. So 0.1539. Now I can get the z-score by using second vars, INV norm, and giving it the left area. That gives me the z-score. And we take that to 2 decimal places. So if I round that to 2 decimal places, it gives me that. Now, it's not going to be that. That's the z-score. We've been asked for the temperature. I have to use the conversion formula. So the conversion formula, I know the z-score. It's x I want. The mean is 98.2. And the standard deviation is 0.62. Again, multiply both sides by 0.62. So the left-hand side will be negative 0.6324. If I multiply this fraction by 0.62, then the 0.62's cancel. To get x by itself, I add 98.2 to both sides again. So I'll just do plus. So it's going to take my most recent answer, 98.2. And those cancel, and I have x is equal to, if I take it to 2 decimal places, I'll get 97.57. Okay. Find the 10th percentile. So what is that? Well, that is going to be the temperature that separates the bottom 10% from the top 100 minus 10%. So from the top 90%. So 10% as a decimal is 0.1. And this right area would be 90% in decimal form. And I need to get that z-score. So if I have the left area, I can do second bars and tell it 0.1 or 0.1000. So it's going to give me that as a z-score. But I need to find the temperature. So A is not correct. I need to find the temperature. Again, I need to get the x. So I've got the z-score. I need to find the temperature. So negative 1.28 times 0.62. So I'm going to multiply both sides by 0.62. So over here I get negative 0.7936. If I multiply this fraction by 0.62, the 0.62's cancel. So to get x by itself, I'm just going to add 98.2 to both sides. So I have x is equal to, so I hit plus over here, and 98.2. And so I get 97.41. Okay, so 97.4. Okay, so that's how I would do it with the calculator. If I'm using the charts to get this z-score, well, a z-score of 0 is there. So I need the negative charts and a left-hand area of 0.100. So I try and look in the body for 0.100 exactly. It's not there. The closest is 0.1003, and that corresponds to a z-score of negative 1.28, which is what I got there with the calculator. So it will work with calculator or with z-score. Okay, so where are we on the time? Okay. IQ scores have a mean of 100 and a standard deviation of 15. Find the probability that a random group of 25 people. Well, if it's a group that I have to convert, then we do have the formula kind of halfway. We put this and this together, and if I put those together, so if I'm doing a group calculation, I have that the z-score of a group is going to be x minus mu, all divided by sigma over square root of n. Okay, so that's going to be my z-score if I'm talking about a group. Okay, so that's my x, that's my mean, that's my standard deviation, and that is our n. So the z-score of my group of 25 people is going to be 104x minus mu all over sigma divided by square root of 25. So in the top here I get 4, and in the bottom this fraction is going to be 15 divided by 5, and 15 divided by 5 is 3, so I'm going to have 4/3 for my group z-score, which is about 1.33. So that's the z-score for my group. Now, what's the probability that the group will have a mean IQ score greater than 104? Well, since it's greater than, I'm going to want right area. So again, I can find out using my calculator what that will be. I can do second vars and come here to the second selection. I want to find this shaded area. I have to tell it left-hand limit and right-hand limit. So I'm dealing with z-scores here. So again, I'm going to have my right limit here to be a z-score of 1,000. So my left-hand limit is going to be 1.33, comma, my right-hand limit is going to be 1,000. And so that area, if I take it to 4 decimal places, is going to be 0.0918. The way I could have done it without a calculator is to look this z-score up in the positive z-score chart. So 1.3 and 3, they meet up at 0.9082. But we have to recognize the charts give us left area. We want the right area. So see how A is the sneaky one there. And the right area is 1 minus the left area, which will give us this answer D. Okay, now we need to find the critical value Z of alpha over 2, corresponding to a 96% confidence level. So alpha, which is going to be the total rejection region, is going to be 1 minus 0.96. But now our critical value, our rejection region is symmetric. It's like a two-tailed test. So our tails have a total area of alpha. And so I'll have 2 critical values here. And each of those are alpha over 2. And we've been asked to find this guy. So to find this guy, I just need to know its left area. Well, its left area is going to be what's not shaded, which is 0.96, plus this tail, which is 0.02. So this guy is what we need to find, and I know that my left shaded area is 0.96 plus 0.02, which is going to be 0.98. So I can take it to 4 places and look it up in the chart, or now that I have the total left area here, I can ask my calculator. So second vars, and tell it I need a total left area there of 0.9800, or just 0.98, same thing. So I get 2.05. Okay. Or if I had, once I figured out this left area, I try and find that area in the body of the chart. So look for 0.9800. It's not there exactly, but the closest one is 0.9798, and that corresponds to a z-score of 2.05. Okay, so I got the same answer. On the critical value, again, Z of alpha over 2 corresponding to a 98.5% confidence level. Okay, so alpha is going to be 1 minus 98.5 as a decimal. Which is going to be 0.015, but that's alpha. So alpha over 2 is 0.0075. So what we've got is 2 tails. Each of them are alpha over 2 because the total shaded region of the tails is alpha. So I've got 0.0075, 0.0075, and the unshaded region is the decimal equivalent of 98.5. So I have two critical values. This is the one we have to find. If I know the total left area, I can find that, either with the chart or my calculator. So this is the guy I want to find. The total left area here is 0.0075 plus 0.9850. Which is 0.9925. Now I can use my calculator or I can use the chart. If I use my calculator, it's going to be second vars, and I have to tell it the left area to get the z-score, and then press enter. So to two decimal places, it's going to be 2.43. Okay, if I didn't use my calculator, I could use the chart. This is going to be a positive z-score. I use the positive chart to find an area of 0.9925 in the body of the chart. 0.9925, there it is exactly. So that area corresponds to a z-score of 2.43, and I get the same answer. Okay, find the critical value z of alpha over 2 if alpha is equal to 0.05. Okay, so again, they're asking us for this guy here. Total area is alpha. Each of these areas will be 0.05 divided by 2. And the unshaded area in the center is going to be 1 minus alpha. Sorry, the unshaded area in the center, yeah, is going to be 1 minus alpha. Okay, so when I add those up, I should get 1. This is the guy I need to find. I need to know total left area. So to get the total left area, to get this guy here, I have to tell it what the total left area is, which is going to be 0.025 plus 0.95, and that will give me 0.975. And if I want to take it to 4 decimal places, I get that. If I know the left area, I can get the z-score. Easy way to do it, or a quick way to do it, is do second vars. If you know the left area, and rounding to 2 decimal places, I get 1.96. Or if I use the chart, this is a positive z-score. I want to find the area closest to 0.9750. There it is, exactly. And that gives me 1.96. All right, a sample is used to estimate a population proportion P. Find the margin of error. That corresponds to a sample with size 1780, having 712 successful outcomes, and this confidence level of 98.5%. Okay, so that's our N, that's our X, and the confidence level is 98.5%, and so the critical value for 98.5% is going to be number 13. That's what we did in number 13. It said you'd need this for other test questions, 2.43. And we got a formula sheet. And what I have here is E is equal to, so from my formula sheet, I'm working with a proportion. It's going to be the critical value times, excuse me, and again. Okay, So I can use the formula if I want to. So my critical value is 2.43. P hat is my sample proportion, which is x over n. So that'll be 712 over 1780. So P hat is 0.4, and so Q hat is 1 minus P hat, which will be 0.6. And N is 1780. So that's one way I can get my margin of error. So I'm going to do 2.43 times square root of 0.4 times 0.6 divided by 1780. Close parentheses, press enter. 0.282. It's going to match up with that one. That's going to be the closest one. Okay, let's see what happens if I try and do this with a test. So I have one proportion, and I'm going to do a z-test. Make sure that the one proportion z-interval. Okay. I believe that's the one I do. So x was 712. N was 1780. And my confidence level was 98.5, so I do 0.985. And then I go down here and I ask it to calculate. All right, so that's going to give me the confidence interval. So what do we know about the confidence interval? Well, that lower level is P hat minus E. And we want E, and we know P hat. P hat is 0.4. So 0.4 minus E is equal to this lower limit. So if I subtract 0.4 from both sides, I get that negative E is equal to negative 0.02824. And of course, the negative signs, I can drop those because they're on both sides. And I could get it that way. All right, there are different ways of getting it. Let's see if I could have used, let's see if I could have used that one. What would that have told me? No, that's for hypothesis testing. So we don't use that one. So the one that was needed for this, but it didn't give it to us directly, was we had to go down here to one proportion z for the interval. That will give you the confidence interval. But you have to recognize, but you do have a formula sheet that the lower limit is p hat minus e, or the upper limit is p hat plus e if you wanted to do it that way. So p hat plus 0.4 is equal to that. So p hat plus e is equal to this. So 0.4 plus e is equal to that. Yeah, that's probably the easier way. So if I subtract 0.4 from both sides, I would have gotten the same thing. Okay. Number 16, use the sample data and confidence level to construct the confidence interval of the estimate of the population proportion P. Okay, so now that they want the confidence interval, I can just probably do it directly, and I don't even have to worry about my calculator using the formula sheets. So the old-fashioned way, before this calculator came in, I would have gotten E from question 12. The critical value is 2.05. P hat would be 206 over 1236. Oops. Which would be 0.167. Q hat would be 1 minus that, which would be 0.833, all over n. So let's see what we have, 2.05. And I can either do the multiplication symbol or just do the square root symbol. 0.167 times 0.833 divided by 1236. And that's my E. And so my lower limit is going to be P hat minus E, and my upper limit is going to be P hat plus E. And again, P hat was 0.167. So my lower limit is going to be 0.167 minus E. And E is 0.0217. And my upper limit is going to be P hat, which is 0.167, plus E, which is 0.0217. And the closest one I've got here, all right, that looks to be the closest. Okay. So, I mean, clearly it can't be anything else. It's not that exactly, but it's pretty darn good. Okay, now, super fast way, go to tests, scroll all the way down to 1 proportion z interval. That's what we want for confidence interval. So X here is 206. N here is 1236. The confidence level here is 96%, so that's 0.96. And then I want it to calculate. Okay. And so to 3 decimal places, that's 0.145. To 3 decimal places, that's 0.188. So again, same answer. Okay, the owner of an online dating website for seniors wants to know the percentage of couples who marry after an online introduction. No surveys exist that give results. Okay, sample size determination. Here is if we have a past sample or survey. Here is where there's no survey available, and we're dealing with a parameter that's the proportion. And so that's what we have here. So N is going to be the critical value squared times a fourth, all divided by E squared. Okay. Now, our confidence level is 98.5%. And from question 13, the critical value I need is 2.43. Margin of error is 3%. If you're given the margin of error as a percentage, then you have to write it in decimal form. So 3 divided by 100 is 0.03. So my answer is going to be 2.43 squared times 0.25. That's my numerator. And my denominator is 0.03 squared. So this is telling me N is equal to 1640.25. We always round up when we're working out a sample size. And rounding that up gives me 1641. Now, Amazon.com is thinking of specializing in online sales of vintage books. We need to conduct a survey of the success rate of online vintage book sales. A recent eBay study shows 93% of vintage books offered for sale online were successfully sold. So our rate of success is 93%. Okay. So our proportion of success is 93%. So that is my p hat. Because I don't have the actual number of successful sales out of total book sales. That's not available. But I do know that the proportion of success was 93%. So I've got that. Now, if p hat is 0.93, 93%, then q hat is going to be 7%, which is 0.07. And the formula I need to use is this guy. So n is equal to the critical value squared times p hat times q hat all over the margin of error squared. Our confidence level is 96%. From a previous question, the critical value for 96% is 2.05. Okay, so this is going to be 2.05 all squared times p hat times q hat all divided by the margin of error squared. Now, the margin of error, we were not given it as a percentage. We were given the actual number. So E is equal to 0.02. If it's a percentage, you convert it to a decimal. It wasn't a percentage here. So I'm going to have E squared, so that's just going to be 0.02 squared. So now I can do this in my calculator. Clear that. So I'm going to have 2.05 squared times 0.93 times 0.07. Then I'm going to press enter. That's my numerator, divided by 0.02 squared. So I get 683.956875. Okay. And so when I am thinking about what's the number, if it's not a whole number, you always round it up. Now, if we were just doing regular rounding, we would round this up, but wasn't the case here. Always round up. So rounding up gives us 684. All right. The EPA has established an air quality standard for lead of that. The measurements shown below were recorded at Building 5 of the World Trade Center site on different days immediately following the September 11th attack. Okay. How many degrees of freedom do we have? Well, is it applicable? And, well, yeah, it is, because we do not know not known here is the population standard deviation, or is it? No. So, what's this guy? Well, if that's their air quality standard, that's their average or population mean. So I've got mu equals 1.5. That's my population mean. That's the standard that the population must live up to. Now, what is the sample mean? And what is the sample standard deviation? Well, I have to put that in a chart, in a list, and I have to get it to tell me. So since sigma is not known, we will have degrees of freedom, and it is applicable. So degrees of freedom is n minus 1. How many things were in my sample? 1, 2, 3, 4, 5, 6. N is 6, so D of F is 5. All right. Now, what is the sample mean? And what's the sample standard deviation? Well, I have to put these in a chart list. So let me clear out list 1 and press Stat and go to the editor. And in list 1, I'm going to put 1.65, 1.1, 0.42, 0.73, 0.48, and 1.1. Then I'm going to do Stat, come over here, go to Calc, and 1 bar stats with list 1. Okay, X bar is my sample mean. And we take the sample mean to 1 decimal place more than the original data. The original data was taken to 2 decimal places. So X bar is I'm going to take that to 3 decimal places. And my standard deviation for the sample is that S of X. And I take that to 3 decimal places, 0.464. Okay, so I've got all of this information. Okay, so what is the critical value required to construct a 95% confidence interval? So I would have needed all of this information if I wanted to go on and construct the confidence interval. What's the critical value required to construct a 95% confidence interval? Okay, so I'm going to have 0.025 here, 0.025 there. These are not z-scores because sigma is unknown. I can't get z-scores. These are t-scores. And for a confidence interval, I just want this guy. So what I need to do is use chart A3 or the t-chart where degrees of freedom are 5. And the area in 2 tails is going to be 0.05. Or I could say area in 1 tail is 0.025. And that will give me my critical value. Now, if I'd gone on to do a confidence interval, then using the chart, I would have to know the sample mean, and I would have to know the sample standard deviation. Okay, so for this test, that wasn't asked in that question, but they could have asked you what's the margin of error going to be. So we have t values here. I do not use z charts. I use the t chart. So degrees of freedom is 5, and area in 2 tails is 0.05. So they will meet at 2.571. Now, if I have, if sigma is unknown, I can't use any of the computer commands, calculator commands that have to do with z-charts. So to get this guy, I have to do second vars, and I have to come down here. And what I want is this guy here. And I know that the right area is 0.025. Okay. Okay, so if I wanted to do that with a calculator, I'm going to need a TI-84 plus. So with the 84 plus, you do second, then vars, and then there should be an INV capital T on an 84 plus. That's not on the 83 plus. So you're going to have to use the chart. So if you don't have an 83 plus, if all you have is an 84 plus, sorry, if all you have is an 83 plus, you don't have the 84 plus, you could go here and do the t-interval test, okay? And tell it you want the data that's, so choose data that's in list 1, and you have to give it your critical level. So here we had 95%, and then you have to calculate. Now when you do that, that's going to give you your interval. So our interval, the t-interval, my t critical interval is this. So it's going to be a lot easier to use the chart. That's going to be my t-interval. Now what is that number there? That upper number there is x bar plus e. So x bar plus e is equal to that upper number. X bar, we found out, was 0.913. So 1.4004 minus 0.913 is E. So if you've only got a TI-83 plus, this is going to be a bit more involved. It's easier to use a chart. But E is equal to the critical value we want times S over square root of N. So to get this guy here, I'm going to need to multiply both sides by square root of N over S, the flip of this. So this is turning out to be really long if you've only got an 83 plus. It's going to be 0.4874 times, I'm multiplying the flip of this fraction on both sides. So I'll have times the square root of N was 6, divided by S, and S was 0.464. So I've already got that times the square root of 6 divided by 0.464, because that's my S. Okay, and so I get 2.573, and out of all of these, it can only be that. So use the chart, it's easier. Okay, now we have a uniform density curve. Calculate the probability that a random variable has a value between 3.5, so 3.5 and 9. So there's 3.5, there's 9, and I need to calculate this area. And the area I'm calculating is a rectangle. What's the height? 0.1. And what's the base? The base is going to be 9 minus 3.5. And 9 minus 3.5 should be 6.5. It's 5.5. So the shaded rectangle is base times height. So 5.5 times 0.1, which is 0.55. Number 22, a sample of 41 actresses. Okay, so that's our N. At the time they won the Oscars for Best Actress category, has a mean age. So this is the sample mean. X bar is 35.8. And a standard deviation, they're talking about the sample. So that is S, not sigma. So sigma is unknown. Again. So how many degrees of freedom do we have? N minus 1. 41 minus 1 is 40. What's the critical value required to construct a 90% confidence interval? Well, alpha is 0.9. 1 minus alpha is 0.1. Alpha is 0.9. And alpha over 2 let's start over again, shall we? I'm getting tired. Alpha is 1 minus 0.9. Alpha is not 0.9, sorry. Alpha is 0.1. So alpha over 2 is 0.05. So the total area in two tails is 0.1, or the area in just one tail is 0.05. Okay, so two tails, or the area, so two tails total, or the area in just one tail. And DF, degrees of freedom, is 40. So if I use my chart, degrees of freedom is 40. And the area in two tails is 0.1. And area in one tail is 0.05. So they'll give you the same column. And they will meet up at 1.684. What is the margin of error required for a 90% confidence interval? Well, I can get that straight from here. So the margin of error is going to be my critical value that I just got in number 23 times my sample standard deviation all over the square root of n. So it's going to be 1.684 times S, which is 11.3, all over square root of n. 41, not 40. 40 is DF. N is 41. So I'm going to have 1.684 times 11.3 divided by the square root of 41. And so my E is going to be 2.972 if I round that to 3 decimal place. So construct a 90% confidence interval. Well, the lower limit is going to be X bar minus E, and the upper limit is going to be X bar plus E. So X bar is 35.8 minus E, so minus 2.972. So I get 32.828. And my upper limit is going to be the mean, which is 35.8, plus my margin of error, which is 2.972. So 38.772. And these are all taken to 2 decimal places. So if I round that to 2 decimal places, and round this guy to 2 decimal places, that's what I'm getting. And so that's matching B exactly. Now, if I wanted to do a t-test, let's see. So I want to do a critical interval, but it's a t interval because sigma is unknown. So I choose that. Now I don't have the raw data, but I do have the statistics. And so my X bar, so here's old data. I'm just going to write over it. My X bar is 35.8. Enter. And my sample standard deviation is 11.3. Enter. N is 41. And my confidence level is 90%, so 0.9. So now I calculate. And you see here that is also matching up to 2 decimal places. That should match up perfectly as well. Okay. All right, now a sample of 100 library users, so that's my N, showed a mean of 24 records. So that's my sample mean. The standard deviation of all, they're telling me what the population standard deviation is. So sigma is known. If sigma is known, it's not applicable to this problem. I don't use degrees of freedom unless sigma is unknown. So what's the critical value required to construct a 95% confidence interval? I did that before. So that was actually number 14. So it was 1.96. What's the margin of error for a 95% confidence interval? So the margin of error, sigma, is known. So straight from the formula sheet, we get that. So times sigma all over the square root of n. Square root of 100 is 10. 12.1 over 10. So I can make the calculation a little bit easier. The 2.372. Okay. And construct a 95% confidence interval. Okay, well, that would be X bar minus E is the lower limit, and the upper limit for the population mean is X bar plus margin of error. So my sample mean was 24 minus the margin of error is going to be my lower limit. And here I'm going to have sample mean plus my margin of error. So 24 minus 2.372 gives me that. And my upper one is 24 plus 2.372. These are all taken to 1 decimal place, so that'd be 21.6, and this one is 26.4. Okay, so if I want to do that with a calculator, I do stat tests, and now we have a z-interval test because sigma is known. And I'm just going to provide the stats. I don't have the original data. So sigma is 12.1. The sample mean is 24. N is 100. And we want a 95% confidence level, so 0.95. And calculate. Okay, and to 1 decimal place, I get the same answer. What is the best point estimate for the population mean? The best point estimate for the population mean is the sample mean, and the sample mean is 24. Okay, that concludes test 3. Okay, and so I did it in just over an hour. I offered lengthy explanations there, okay, but hopefully if you missed anything, if you understand what went wrong, you will be just fine.